Good morning, everyone, and welcome to Net Zero Week, the Awareness Week's keynote presentations just before the kickoff of the actual week itself, which will start next Saturday and run for the entire week next week with a load of webinars and special podcasts and broadcasts about to help you on your journey. There's over 30 of them available, actually, with over 50 associations and partners, all hosting their own. You obviously go on the Net Zero Week website to find details of those particular ones. And we're looking specifically now at the electrification of UK PLC, and whether we see the electrification of the majority of heat transport, as well as all the power requirements, green power requirements today. There's obviously intermittency, and is battery storage enough? Will that work? Will that be cheap enough? And will EVs be used as part of the solution? So to sketch out the entire sort of the look of the picture and the energy mix, we've got a couple of people with us today. We've got Di Richards from Hitachi ABB and Chris Gent from the CCSA, which is the Carbon Capture and Storage Association. They'll both give their viewpoints, and then hopefully you can put questions to them via the question pane on the right-hand side of your screen, and just feel free to ask questions at any time, and I'll then put them to our guests. So Di, handing over to you. Yes, what's the picture going to look like in the next 20 to 30 years?
Okay, thanks, Tim. Can just confirm that you can see my slides?
Yes. Yeah, no, that's great.
Okay, well, good morning, everyone. I'm Di Richards. I'm the External Affairs Lead for Hitachi ABB Power Grids in the UK. I was going to give you a very quick introduction to the company for those of you that aren't familiar with us, and then offer our perspective on the changing role of electricity in the energy system going forward. Hitachi ABB Power Grids, we actually celebrated our first birthday at the start of this month, and we're part of the Hitachi group. Hitachi, for those of you who don't know, is a Japanese-based global organization, very diverse. It's very large, so it's about a £60 billion turnover, 350,000 people across the world. And interestingly, as we joined, what we learned is that some of the sort of modern corporate values that many companies have adopted over the last few years are actually things that were enshrined in Hitachi when it was formed over 110 years ago. So the original vision for Hitachi, and it remains the vision today, is around delivering innovations that answer society's challenges. So that sort of societal element has always been a big part of the Hitachi culture, and it's interesting to join an organisation that culture puts sort of social values and environmental values up there, along with the more traditional economic values, and certainly that fits very well within the net zero position that we find ourselves today. And as Power Grids, we sit within the energy business of Hitachi. So Power Grids ourselves, we're actually a joint venture between ABB and Hitachi currently. We are the global leader in our sector. We're headquartered in Switzerland and operate worldwide, as you can see, with about 36,000 staff and a large number of people, and a big focus on R&D and innovation. If you look at the sort of lowest, the bottom pie chart there, you can see that we're pretty balanced across the world in terms of our operations. And if you look at the top chart, you'll see sort of it reflects a bit our historic position, that we're really a provider in the electricity grids area, supporting mostly power utilities and sort of major industrial users of power. But that is changing fast as the role of electricity in the energy system changes, and we'll come back to that shortly. I put this slide in for a few reasons, partly because we're proud of the numbers, to be honest, but also to make a couple of key points. Firstly, I wanted to highlight the sort of technologies that are going to be important in ensuring we have a resilient modern electricity network that's going to be essential in terms of delivering the energy transition. First of all, highlight a couple of technologies there. So FACT stands for Flexible AC Transmission System. So sorry about the acronyms, but really wanted to highlight flexibility there. So that's flexibility in the normal transmission systems that operate in pretty much every country of the world, and that flexibility is going to be absolutely essential to make sure that we can have a resilient network as we increase the amount of less dependable and less predictable renewables. I've also highlighted HVDC there, so high voltage direct current systems, and they're again becoming increasingly important. Historically, they've been about connecting grids in different countries, so interconnection between different countries' power systems. But increasingly now, they're also being used to transport renewable power from often remote places where it's generated, and bringing that into where it's needed with minimal losses across the system. So increasingly important technology. And finally, I've highlighted software there. The changes in the way that the grid operates that we might get into really means that digital solutions are being relied on much more to make sure that we control that grid stably, and make sure that the grid remains resilient. But also about how we manage the assets within that grid more effectively and more energy efficiently, again, is an important factor of how things are managed nowadays. The second thing that or reason for highlighting that is, again, to reinforce where we've come from in terms of a provider of equipment and solutions to the transmission and distribution networks. But as I said, that's really changing at quite a pace alongside electricity's change in terms of the role that it plays in the energy system. So what we see is that the whole energy system's evolving towards carbon neutrality and net zero, but we see electricity absolutely as the backbone of that entire energy system. The transition's really driven by three things. So we all know about the shift from fossil fuel generation to renewables. That's a key driver of the transition, and also increasing amount of electrification into other sectors. So transportation, built environment, industry, data centers is highlighted on the slide as a sort of key and growing consumer of electricity. And finally, we see sort of other energy carriers, sustainable energy carriers coming into the system, such as hydrogen. So what kind of things are we seeing? We're seeing a change in the way that electricity is perceived. So electricity is being seen as, or it was seen as a secondary energy source produced from fossil fuels, and now very much being seen as really a primary energy source coming from renewables. The complexity of the system is growing and increasing very much every day, and that makes the system increasingly dependent on digital technology. The operator's role of energy systems is changing from being a provider of power to becoming a manager of energy. And it's also clear that coupling of the different components of the energy sector is vital. So how does electricity and hydrogen, how do they work together, and how do they support each other is becoming increasingly important. And that means that as an organization, we've had to evolve. So very much now the range of things we get involved with extends way beyond the power grid into transport, into cities and built environment, into hydrogen, etc. And it also means that we have to think very holistically about energy. And really the evolution of our organization reflects precisely the way that electricity is evolving its role within the entire energy system. And our purpose, just down at the bottom of the slide there, which is powering good for a sustainable energy future, really does fit very well and reflect very well with the changes in the evolution of the energy system. Our full purpose talks about doing that through innovation and doing that in collaboration with, whether that's with industry partners, with governments, with industry organizations, and both of those are going to be vital to make sure that we achieve the end goal, which is really to provide a stronger, smarter and greener electricity grid. I mentioned at the start of my talk that we've just celebrated our first birthday as being part of the Hitachi group, and as that on that occasion we also announced that we're actually changing our name to become Hitachi Energy, which again reflects the evolution that we're seeing. So final thing I just wanted to say, it is a bit looking at what do we see as the challenges through increasing electrification. What are the changes that need to be made? And we really look at that from three points of view. So from the environmental point of view, so what are the environmental drivers for the changes and the challenges? What about the resilience of the system that needs to be maintained? And finally, the need to make sure that we maintain security and safety across the whole power grid. So maybe just picking up them, looking at them one at a time. If we start with environment, so obviously renewables is the big driver there, and moving from, in the UK, roughly where sort of half of our electricity comes through renewables at the moment, that's got to go up substantially at the same time as electricity demand is going to double. So there's a huge increase in renewables that needs to be accommodated. Energy efficiency is something that really shouldn't be forgotten about. It's often the sort of orphan of the energy space, something that people don't particularly pay enough attention to. But energy efficient, and any energy saving should be viewed as another source of energy. It's the sort of lost energy vector. And it's not all just about carbon reduction. So there are other environmental factors that we need to think about as we go forward. So things like SF6 gas, which is common across the whole of the power sector, is many times worse contributor to global warming than carbon dioxide, and so switching SF6 out to alternatives that are more carbon friendly is an important trend that is starting to happen and needs to continue. But also things like minimizing the impact on the environment visually of electricity infrastructure is something that's becoming increasingly important. In fact, we launched a competition recently aimed predominantly at architectural students to come up with some designs that are going to be much more sympathetic for infrastructure to fit into the local environment and minimize the impact. And sort of final point from environment is obviously about electrifying everything. So electrifying transport, built environment, and industry to help reduce global warming. Briefly, just to touch on resilience and some of the challenges there. I mean, this is driven by the intermittency, by the variability within renewables compared to the more predictable sort of fossil fuel generation that we've been used to historically, and that's going to really put more emphasis on the need for digital technologies within the system that can cope with the increased complexity, cope with the sort of fast moving swings in generation, and make sure that the voltage within and the frequency within the system remain stable and keep the whole system robust. Is going to become very important. There are technologies out there, so power electronics based technologies are at least part of the answer to that problem, and replacing some of the stability that's been provided by sort of spinning generators historically. And energy storage also plays a big part in that, both from the stability and making sure that we don't have to curtail some of the renewable generation that is now available. So they're all going to be important factors going forward. And a final one to perhaps pick out of the security and safety area is the need to make sure that we stay on top of cybersecurity. I think most people will be aware of some of the issues that have happened in the US to some of their energy systems recently, and the need to make sure that that systems remain available, remain resilient under cyber attack is again going to be increasingly important. And that was all I wanted to say as a start, Tim.
No, that's great. Thank you. I'll hand over now to Chris, who can explain the CCSA's view on what's happening in the next foreseeable future with regard to heading towards net zero. Chris, over to you.
Thank you very much, and thank you for inviting me to come along and speak at this session this morning. Yes, as mentioned, I'm Chris Gent. I'm a policy manager at the Carbon Capture and Storage Association, and we are the trade association for companies interested in the commercial scale deployment of carbon capture and storage in the UK, in Europe, and we also cover some of the actions happening globally. We were established in 2006, so we've been through a couple of cycles, should we say, on CCS, and we operate as a traditional trade association. But obviously, at the moment, CCS is on the sort of the government's agenda, and the drive towards net zero has really pulled out, really drawn the requirement for CCS out, particularly in achieving net zero and addressing some of those negative emissions questions as well. But in terms of electrification versus hydrogen, decarbonisation through electrification of the whole system, you know, the CCUS has a role to play regardless of the pathway that we take going forwards. And I think it's really important to understand that the flexible capacity that CCS can enable by decarbonising flexible generation through gas CCGTs will have a role to play in particularly in an electrified system where you need, you know, a backup capacity for those weather events, for example, beast from the east events, where we need that flexible backup capacity to ensure that we can come through those scenarios. Now, if you look at a more hydrogen-based heating and potentially transport-based system, CCS has a role to play there as well in enabling those volumes of hydrogen, particularly in sort of the 2020s, 2030s, to come online at scale, which can be used by industry and reliably, as well as CCS also providing backup capacity if needed, or hydrogen volumes to have that flexible capacity, and importantly as well,
Sorry about that. It appears that Chris, you dropped out there.
I think I dropped out there. How far did I get? Where was I? Apologies.
Right, you're back on. So you've done your intro basically, and then it was when you were just going into the policy of, you mentioned green hydrogen and the fact that there's not enough and CCS would be needed in that.
In hydrogen.
Yes.
Right. Okay. Rewind a bit. I think I was talking to myself for a while. Then apologies for that. So I'm basically saying that for hydrogen to deploy, it doesn't matter if it's blue or green. The pathway towards net zero is going to need both. And I think if you have a hydrogen pathway for heat and transport, you'll need CCS to enable that. Particularly in the early stages, to set up those market conditions, enable some of the infrastructure to really deploy at the scale that we need to move forwards. And importantly, across both either electrification or sort of hydrogen scenarios, there will be quite a large role for bioenergy CCS. So the CCC and other commentators have highlighted the real need for CO2 removals to achieve net zero. And bioenergy with CCS, as well as direct air capture, can provide that valued and verifiable CO2 removal service. And obviously with bioenergy with CCS, there is an potential for electricity generation alongside that, providing a potential base load going forwards as well. So for the CCSA, for the CCUS, it doesn't really matter which pathway we take in terms of the electrification versus hydrogen. CCS will have a role to play in any scenario, but obviously depending on the rollout of these technologies, there's implications across the energy system, implications for how the CO2 networks are designed. And if you look at what's going to be happening in the 2020s when these first clusters are moving, I think we need a bit of clarity to really understand what the routes forward are from government. And I guess the hydrogen strategy is one area that we're very interested to understand how government envisages that working, because obviously we have to right size the pipelines to go in the 2020s to be sure that we can make sure everyone has access to that infrastructure moving forwards. So I'll stop there. There's an awful lot to dive into, and I welcome any questions and discussions.
That's great, Chris. Great, thank you. So going back to the hydrogen scenario, why would it not be the case that you could just get green hydrogen? Because you'll have if you went all electrification, you'd have an enormous amount of renewable energy that would equally blow at times you don't want it to, and you could technically electrolyse that and make hydrogen. Would be one argument. Why is that probably not the case?
Do you want me to jump in on this one, Di?
Yeah, sorry, yes, yes.
That's for me then?
Yes, it is. Yeah.
Super.
Add a comment at the end.
That's fine. And I think if you look at the hydrogen, particularly one of the early uses for hydrogen will potentially be either in sort of power generation or used for industry. So fuel switching for heavy industry is obviously one of the key sort of end use markets for hydrogen. It's quite a straightforward process compared to putting it into the grid and getting it into homes in terms of how quickly that can roll out, and also in a sort of a cluster model. And one of the more difficult conversations to have with industry is if it's on electrolysis based on renewable electricity, it's slightly more difficult in the near term to assure that those volumes will be available for those processes which need hydrogen constantly. So obviously one of the benefits of having blue hydrogen, as it's called, or low carbon hydrogen, however you sort of term it, is that reliability, and obviously enabling those volumes at scale as well, that, you know, so you can have a contract which you can sort of rely on, and your investors can get behind, and there's not so many risks, at least in the near term. Obviously over time, as electrolysis and renewable capacity expands, then you'd see the shift. There would be a shift to tend towards more green approaches, green hydrogen electrolysis approaches, and that's something that, you know, we recognise, and the shift will change over time. It will change in different countries and different regions, will have different pathways given their current energy mix and potential in the future. So it's quite a complex answer, but I think there's a lot of the heavy lifting can be done early with the volumes that the CCS and blue hydrogen can enable, particularly on some of those networks, those regulatory issues, and just providing that early markets for hydrogen.
And I wouldn't disagree with what Chris says. I think it is all about how quickly production could be ramped up, and it's difficult to see that green hydrogen production can ramp up quickly enough to keep up with demand. So I think at least as an intermediate step, blue hydrogen will be an important part of the mix.
Is your opinion that hydrogen is necessary to the mix, future mix?
I think I'm just perhaps finished one thing on carbon capture that I guess, I mean, Chris mentioned this, that bioenergy with carbon capture is I think most people agree is going to be an important part of achieving net zero. So that certainly needs to be part of the future mix. But I think, I mean, hydrogen will play an important role in the future. How far it goes into things like heating, I think is a question that still needs to be answered and fully explored. But certainly it will have a role in transport, either sort of fuel cells or as alternative fuels, synthetic fuels. So it will have a role in the areas where electrification won't be the sort of practical solution.
I've got a question here. It says, the big issue I see for UK is not generation but power delivery. Around 80% of UK homes are supplied by networks fit to deliver no more than 1 to 2 kilowatts continuous.
Yeah, and that I mean, I think that's one of the things that needs to be looked at. If you look at the big growth in demand is going to be for electrification. Going out to households anyway is going to be around electrification of vehicles. So how can that demand be met, and also heating? So if we go down the line of predominantly electrification of heating and heat pumps, etc., then there will be an increased demand into homes. Not all of that needs sort of more cables in the ground, and I think that's that's part of the solution is going to be sort of smarter systems. So demand response within people's homes, and flattening out the demand profile through smart charging of cars, through using cars feeding back into the grid, so vehicle to grid technologies, local storage, be that on a distribution network or within people's homes. So all of that will reduce the peak consumption and level that out. But there will be a need to expand the distribution networks and invest in more copper. And I think we can avoid that.
Mm-hmm. This one's to Chris, and it says CCS is only up to 95%, often less. So how do you improve the capture to 100%?
That's a very good question. I think the number on the capture limit is often changing. So I think if we had this conversation 2 years ago, 3 years ago, it would have been 90% would have been the question. Now it's 95, and there are studies to say that capture rates can go up to 97, 98, 99%, depending on the process, with in some cases minimal increase in the potential capital costs of that process. So I think obviously we're at the early stage of CCS deployment in the UK, very early stage. There is a potential to increase that number. Obviously, as the technology deploys, we learn a bit more about where we can save on those residual emissions moving forwards. But there potentially will be an amount that is a residual, and I think that also echoes across in other sectors where there's always going to be an amount that's emitted somewhere, particularly in those harder to abate sectors. I mean, obviously some of the CCS users will be industrial users who have no options, no alternatives, for example, cement and iron and steel. So that sort of really ties back round to this negative emissions piece, being able to have those technologies that can account for those residual emissions moving forwards. And obviously bioenergy, CCS, direct air capture are two of those options.
And sorry, what was this? Where is the role? Where do you see the role of electricity storage heading? Is that at industrial pump storage level, urban smart city level, or domestic Tesla walls and use of storage and plugged-in EVs? Probably more for Dyna, but yeah.
I think, yeah, I mean, yes to all is going to be the answer to that. So I think, you know, large scale sort of grid scale storage is going to be an important part of the mix. I mean, and that serves a number of functions. So not only can it be used as a store of renewables when generation exceeds demand, which is one important role, but also battery storage is a way of providing some of the sort of grid stability services that will be important to make sure that the system remains resilient. But locally, it will also be, you know, household storage, whether that ultimately ends up being through a domestic vehicle, or whether it's a local storage solution will be part of that, and you know, and sort of distribution level storage, whether that's part of an EV charging hub, for example. So I think big charging hubs, battery storage is an essential part of the effective operation of those hubs, or whether it's you know, a commercial area where battery storage will be used to provide sort of stable power to a group of commercial buildings or residential space as well. So I think all of them will be important and all play a role, and likely will fit in alongside other storage, you know, non-battery storage solutions as well. Whether that's sort of pumped hydro scale, or whether that's hydrogen storage as a sort of longer term storage mechanism as well. They all play their part.
And going back to the big issues, not generation but delivery, the person who asked it said no, inadequate, simulated 5 billion EV trips, no smart way out, smart smoke I call this. Alas.
I mean, I think, as I said in the original answer, smart is part of the solution, but we can't get over the fact that the network needs to expand physically. We need to use smart solutions as much as we can to reduce the cost and disruption of expanding the network, but we need more network reinforcement, absolutely, as part of the answer.
And by smart, you're meaning flexible, time of use, things like that.
Yeah.
Yeah. And the what was this one? Sorry. Oh, do you have any information on direct air capture technologies of carbon?
Yes.
That could be either carbon capture. It's a capture form, obviously. It's not maybe.
Yes. So direct air capture, there are several companies around the world looking at direct air capture. So, for example, Climeworks is one of the sort of major players, as well as Carbon Engineering. And there are projects proposed or sort of under feed in America for direct air capture at the sort of thousands of tons, hundreds of thousands of tons per year scale. And direct air capture are also looking, Carbon Engineering, are also looking at direct air capture opportunities in the UK as well. So they're linked up with the Scottish CCS cluster. So they're looking to be providing direct air capture services in the UK in the 2020s. There are several different technologies that there's sort of solid versus liquid processes for direct air capture. They have their pros and cons. I'm not a chemical engineer by background, so I can't necessarily dive too deeply into the specific differences in those. But the technology is moving from sort of that pilot demonstration scale and looking towards commercial opportunities in this decade. And if not in the UK, then there's quite a positive market in America for direct air capture technologies in North America and Canada and the US. So it's definitely something that's moving ahead very quickly.
I was going to say, what application specifically is it more likely to be targeted and used in?
There are several potential options. I think one of the key areas that we're working with our members to discuss at the moment is the actual business model that sits behind greenhouse gas removals. So what is the price of that removal, and how do you structure the market appropriately? How do the voluntary markets come into that? There are a lot of companies, Microsoft, etc., willing to pay quite a lot of money for verifiable CO2 removals. I think we're still in quite early stages of understanding how the market may change over time and what instruments we need in the near term to make sure those projects can actually deploy and then explore the market. There are also other areas around direct air capture, so potential to use direct air captured CO2 with green hydrogen or blue hydrogen perhaps, but mainly green hydrogen, and create synthetic fuels. And this is something that the aviation sector are very interested in investing in moving forwards to help them decarbonize. And obviously, I think that's a huge topic in itself, but I think there's one of the hardest to abate sectors going forward will be the aviation sector, and they are inextricably linked to the direct air capture.
Okay. Di, well, UK's a net importer of electricity, and could that change with our increase in renewable generation? Do you think that's something that will happen?
Yes, I think it. I mean, it should. We have a fantastic resource in terms of the wind around our coastal waters, and potentially some of the marine resource if the technology can advance and come down in cost there. So I think in the National Grid released their future energy scenarios at the start of this week, and I think all of the scenarios that they model all show us becoming a net exporter of power in the next in sort of 2 decades time. So I think that will happen. I guess the other interesting question is where do we get on hydrogen? So could we also become a net exporter of green hydrogen? That would be I mean, it would help as part of our sort of green recovery if that could be a resource that we can utilize to get the value of export from hydrogen too.
Absolutely. Here's a specific question. I don't know who particularly aimed at, but probably you see the role of do you see the role of small modular molten salt reactors to replace gas-fired boilers in our power stations?
Exactly. Yeah. Not an area or not a technology that I particularly am familiar with, I'm afraid. I mean, I guess with all of those things, and it'll come down to ultimately to the economic case for that. I think we will well understand from a generation point of view. We understand what the economics of offshore wind are, and anything that can compete against that is something that we should think about in combination with storage, which I guess is where that kind of solution would come to the fore, is where we depend on storage when the sun's not shining or the wind's not blowing.
There's a very quick question here. Does Hitachi supply electrolyzers? Sorry.
Not something that we do currently.
No. Okay. No, that's good.
Quick answer.
Yeah. No, the increased share of renewables feeding the grid could lead to instabilities in the system. Do you think? I mean, obviously we had those blackouts just the other year, didn't we? In August, and you know, what are the, and that was to do with the trip and local distributed generation and stuff. So what are the challenges ensuring capacity is maintained?
Yeah, and I sort of touched on this a bit in the introduction, that it is one of the major challenges. So I think the sort of instabilities that you get when you sort of get voltage spikes, for example, in the system, if suddenly you get a gust of wind, and how does the system sort of dampen either drops or increases in voltage or frequency as it hits the network is a major challenge. Sort of in the when we depended on sort of central spinning generation, it was very predictable what the outputs from those generators would be, and you know, minor variations from a trip somewhere could be easily accommodated. The system is much more variable now, so it does need some of the solutions that I sort of referred to as the power electronics solutions. So there are sort of either independent devices that can react very quickly to sort of voltage spikes and compensate for them, in conjunction with sort of battery, so the grid scale battery storage that we were talking about before. In combination with those, they can manage some of those fluctuations and prevent blackouts, or in the worst case, help get the system started again. So there are an increasing number of technologies that will help overcome those issues, but it is a real problem, and we do need to invest in installing some of those new technologies, and making sure that the sort of control systems that manage the network again can cope with that, and that you know, we can sense those changes as they're coming, or predict them by you know, I think the future will hold the use of AI to sort of predict some of those issues due to changing weather patterns, for example, before they actually occur, and better prepare for that, and better model what the response should be to allow for that.
Okay, that's interesting. Yeah, as in the AI bit, yeah, that you could actually predict it with a lot more accuracy. The coming back to the role of smart charging, this question says, and time managed solutions. Do we know what the difference is between daily peak and daily average electricity use, and and therefore the underused capacity of what the grid might be, what the underused capacity might be?
And I'm just looking at the kind of latest information from National Grid to answer that question. I mean, yeah, peak demand and sort of installed capacity are it's kind of 50%. So there is a lot of scope to level or still a fair bit of headroom to level demand.
Okay.
If that answers the question. And that obviously depends on where in the net that's overall in the network. So it obviously depends where you are.
Locally,
there are some places that have got no local capacity, and some that have a lot. So it does depend how many EV chargers you're trying to run simultaneously in your street, etc.
This is interesting, just the ballpark figure. Roughly, when would you say that electricity will be the main source of energy in the UK, e.g. above 75%?
I mean, it's got quite a long way to go.
What is it currently in energy?
It's below 20% now.
Yeah, okay.
So, you know, it will be it'll be driven by the speed of adoption of electric vehicles, but also very much what happens from heating and taking that over from gas.
Someone's just answered 2040. Just given an answer.
Okay.
So how do you see the role of flow batteries alternatives to lithium-ion power storage?
I guess that's to me as well.
Yeah.
I mean, I think, you know, battery technology across the whole of electrification is going to be absolutely critical technology. So finding batteries that are that have higher power density, that rely less on sort of rare earth resources, again, is going to be key. How the sort of, you know, the fast acting requirements of batteries that sit within vehicles, for example, versus the sort of lower performance that can be accommodated in some of the energy storage systems, and how you sort of preserve the inherent value of batteries that perhaps are being used in a vehicle and having a second life as part of a grid storage system. All of those issues are going to be critical. So batteries or the speed with which battery technologies are developed that are cost effective, are more sustainable, have increased performance, it will impact all sectors, I think. And hence you see, you know, a considerable effort going in from an R&D perspective, and the work of people like all the groups like the Faraday Institute to develop those. It is something I think we all hope succeeds with pace.
Chris, you mentioned gas peaking technologies and gas-fired electricity generation. Are there any scenarios you know where that's not needed, or is that an essential technology that, you know, will be required on our net zero journey?
I think if as far as I'm aware, I haven't seen any scenarios where there isn't a role for that backup capacity or that flexible generation capacity. I think if you look at well, it was already mentioned, the future energy scenarios released on Monday. There's a whole piece in there around that flexibility. If you look at the CCC's work again, the Climate Change Committee's work again, that they touch on it. And the National Infrastructure Commission released a report last year which dived into the requirement for flexible generation capacity as well. And BEIS have also modelled it in a lot of their electricity generation costs and their planning going forwards, and they use a enhanced levelized cost, which I guess takes into consideration the sort of the wider impact of having backup capacity on the network. So I think, as far as I can tell, and as far as the information that I've read, you know, there is a role for that flexible backup capacity moving forwards. There's also a role for as we discussed, the battery storage moving forwards as well. And also the whole hydrogen discussion, hydrogen storage, how does that interact with the energy system going forward? So an awful lot of variables at the moment, and that's why these discussions are so interesting.
We've got one here that just agrees with you. Essentially, it's saying National Grid own about 2% of the cables and C averages. The other 98% is owned by distribution companies, often with negative peak headroom. Local is a different ballgame. So yeah, no, essentially.
Yeah, no, I agree, and I think there's some momentum building up behind this idea of sort of local energy planning, sort of being very much what we need, and I'd say energy as opposed to electricity. So I think, you know, strongly believe that thinking holistically about local energy needs, how demand's going to evolve, how you best design a system to meet those future energy needs, or to encourage development in areas where there's excess power or whatever, is an important part of how we plan for the future effectively. Because certainly thinking about how we do charging in isolation with how we do heat pumps, or how we do storage systems, will end up with a suboptimal solution and end up with digging the roads up 5 times instead of once, those kind of issues. So I think the need for that local plan built around knowledge of local demand and local sort of future plans is going to be critical, and the challenges will vary depending on where you're based, how future developments are going, and what the local capacity and the headroom is already.
This is a specific one for you, just on a guy. Does Hitachi plan to deliver hydrogen-powered trains?
We are. I'm not from the rail business, so not an expert on this. I should say, but we are involved in a pilot project at the moment to deliver some hydrogen-powered trains. Yeah, but certainly, I know that the rail business is looking at hydrogen. I mean, it's also very much looking at batteries. So if you look at the UK, I think we're a bit under 50% of our rail lines are electrified. So obviously the future needs to tackle that problem either through hydrogen or through battery trains, or through accelerating the electrification program. But certainly, we see that providing battery trains is a quicker and easier solution than providing full electrification, because you can actually charge the trains sort of intermittently along the route, and do that at a place where there is availability of power, and where it's easy to get to. Where it's easy to get there to install the infrastructure that's required. So I think battery and hydrogen will both play a role on different routes, again based on local solutions and availability of power.
Yeah, fundamentally, obviously, you started off by saying and it's sensible. Electrification is a key, and we have to electrify as much as we can, and so on, and generate. But do you actually see domestic heating? If transport we take as going predominantly electric, certainly for passenger vehicles, and then can we do? And then maybe certain industrial processes, well, they've got their individual needs, which will be maybe using carbon capture and storage or something if they simply can't electrify their processes. But what about domestic heating? I mean, that's a huge load that you're then putting on potentially heat pumps electrification.
That's one of the big decisions we'll have to make as a country, I think. So at the moment, there is there's a focus on both exploring hydrogen for heating. So the trials that are going on, starting with a sort of relatively small number of houses, going to a village, potentially going to a hydrogen town by the end of the decade, is the sort of published plan, and looking at the feasibility of that. In parallel, there's obviously a lot of emphasis on heat pumps, and how households can be encouraged to go down that route. Again, I think it will. Personal view is that I think it will be a mix of both solutions. So in some situations, a heat pump will be the right answer, and the most appropriate for the local energy resource. In others, it may well be that if hydrogen sort of passes through the trial successfully, then that might be the most appropriate solution in some areas.
You see the big role for heat networks?
I think the challenge for those is infrastructure. So again, in a situation where there's a local industry, for example, that generates a lot of excess heat, then it has to make sense for some kind of heat network to be installed. That won't be the right solution for everywhere. I think that the challenge we've got is probably not so much new build, but retrofit of our existing housing stock. That's sort of the big challenge. So we've got both electrical infrastructure and gas infrastructure, and it's making the most of that where it's suitable. And we'll have to see where it goes. I mean, my understanding is that from a cost point of view overall, it looks fairly similar from a sort of system point of view to do hydrogen conversion versus doing or moving to heat pumps. But again, I think that will differ.
But of course, because the homeowner, it'll be a question of who pays for it or how.
Yeah. No, and yes, we haven't really talked about how do you finance this, but that's probably is one of the main challenges.
I think that's why domestic heating's got a challenge, is that it's people's homes and they get a lot more protective over, rather than the industrial process changing. It's just a logical decision, and that's that.
Yeah. No, and we've come a long way in terms of carbon reduction, but really without individual homeowners being hugely involved in that process. So moving to renewable generation and the success that the power sector's had has been sort of system led and business led. We're really at the stage where we need to involve, the whole nation needs to be involved in the next steps to get us towards net zero. I mean, not just from an energy point of view, but they will play we'll all play a major part in energy, the energy transition, based on some of the individual choices that we make.
Chris, do you have a view on the domestic heat and how that's going to be potentially be achieved, the transition to low carbon domestic heat? Or have you frozen? Yeah, okay, I'll leave that for a minute. Yes, it appears to have frozen again.
Yes, perhaps I should have frozen at that point. I mean, maybe one other point on that, Tim, is we haven't really talked about skills, or the upside of some of the the transition. I mean, there is a question of how we fund this. I think if you look at the Committee on Climate Change sort of economic assessment of net zero, by the time we get to 2050, there's a net economic benefit. So it really is how do we make sure that the transition is done fairly and equitably, and that there isn't a disproportionate gain or cost to different sort of sections of society, but overall the answer is that this is it's a net positive thing for us to complete the transition. But there is a challenge in terms of skills. So if whether it's converting boilers to work on hydrogen or whether it's installing heat pumps, we need to have a skilled workforce to carry out those installations, to the right standards and do them most effectively. And we also need to increase the level of skills that we've got in local authorities and elsewhere to help do those sort of coordinated local energy plans that I was talking about. So certainly that's the skills challenge in lots of areas is something that needs to be tackled urgently if we're going to deliver any of these solutions successfully.
Chris, you look to be back with us.
I'm back. Yeah, sorry about the well-timed drop off of my internet as soon as you passed over to me. I came back just as Di was just talking about skills, and that would have been, the key point that we see is, regardless of, well, if you head down either route, there is a need for those skilled engineers, the skilled labour force, to actually implement the changes, because the challenge ahead is vast. And I think I'm not sure someone sort of sat down and really thought through how we engage not only the current skills force, but the students in the colleges, that schools, who are going to be basically doing this potentially over the next 20, 30 years, and being able to have that workforce to come through to enable these changes is really vital. And it's something that some of the gas networks are beginning to wrestle with, and I know that they're keen to ensure that messaging is fed through across the board and into the local authorities, who can help with some of the colleges to actually introduce and engage with the communities to make sure that some of the skills forces are beginning to come through.
And one question I had when you dropped out was whether you have any view on the transition of domestic heat. Oh no, he's done it again. Every time I ask a question. Are you with us? Yeah, good.
Yeah, I'm here. Try again. Sorry.
Yeah, no. So the domestic transition of domestic heating to low carbon. Do you see a particular route being taken? Electrification,
yes, and
heat pumps or heat networks or whatever.
Yes. I think the jury's kind of out. I think that it's a regional. It depends where you are in the country. I think there'll be some areas that have access to quite readily have access to certain infrastructure. For example, if you roll out hydrogen, then some towns near where the hydrogen is being produced can potentially tap into that. But there are other areas that electrification is the most suitable option. I mean, there's been a lot of work being done on this. The CCSA have done some really good analysis on the nuances of what that may look like in the future. And I think that's one of the big sticking points of the heat and building strategy and the hydrogen strategy, that we're overdue. I think once they come out, then it will give companies a bit of an onus to sort of actually begin to develop plans, because at the moment, with a lack of direction, it doesn't necessarily bring people around the table to discuss how they're going to work with government to achieve the goals, and government haven't necessarily outlined what they envisage the goals being, if that makes sense.
And so carbon capture and storage on technology is, with regard to, I don't know, putting it on, say, a combined cycle gas turbine, is there now ready to install? I could literally plug one in today.
On a CCGT?
Yes. Yeah.
Yes, I mean, yes. So the technology is operational globally. So other countries have been operating CCS for a long time, both in power and hydrogen production, gas processing, various applications. It's not a simple case of just being able to plug it in now, I think, because there needs to be the infrastructure built around it. And that's the whole point of the cluster proposals, the clusters that are moving ahead. So it's bringing together several users of that one network in one process, and sharing the risk and cost around a bit, and making sure those clusters can deploy together. But once that initial network's up and running, and we have experience, it'll be, I wouldn't say straightforward, but it'll be an easier process to say that you'll retrofit a CCGT or even build a new one, potentially with CCS or carbon capture unit attached to it.
And what's the most obvious options for the actual storage? Where it will be stored in the UK?
So offshore. So in the same, I guess, CO2 storage uses the same principles as oil and gas trapping in sort of a geological sense. So in the same sort of formations and storage reservoirs, we term them, where you have let's say a sandstone, which has a cap over it, so an impermeable layer. It's the same, effectively the same principle, where you inject CO2 into that reservoir to store it permanently. And obviously the UK's got quite a large offshore space. There are plenty of storage, it's a large sort of potential storage resource. I think estimates are around 78 gigatons worth of storage capacity in the UK offshore. So we're not short of places to store it. And I think an interesting potential option in the future is to actually import CO2 captured in other countries to help them with their decarbonisation process, because we've got a huge storage resource going forwards. But lots of potential places to store it in the UK offshore sector.
I've just had a question come in that's how do you feel about the cancellation of the Green Homes Grant, and will it affect the accessibility for renewable energy solutions, especially for working class, low income households?
I can have a I can have a go with that. I think we did some thinking about this as part of a group that Hitachi ABB Power Grids was part of, was a thing called the COVID Recovery Commission that was looking at some of the things that can be done to but stimulate sustainable growth going forward, and a lot of sort of green recovery recommendations were made as part of that. One of those recommendations was sort of looking at that issue. So it's back to the challenge around retrofits of existing housing stock, and what needs to be put in place to make sure that that can be done successfully. And I think there are a number of factors that need to be in place. And hopefully there's some learning from a few schemes that have been in place in the past to try and tackle this that haven't been successful. So I think one thing is having a sort of longer term certainty. So rather than offering something that is available for a few months and the work needs to be completed in a few months, and everyone then panics to try and come up with a quick solution without having done the proper skills training, the proper planning, etc. I mean, as Chris was talking about, we need to be engaging with people who are still in full-time education at the moment to try and attract them into some of these important roles to support the energy transition, and you can't do that in a few months. So we need a long-term view about stability of if government's going to provide support, then we need a 10-year plus view about what that support's going to look like, to allow the skills to be developed to support doing that, to allow industry to invest in setting that up. So if we can have a supply chain that manufactures more heat pumps in the UK, provides installation services in the UK, helps the expansion of the distribution system that we've talked about in the UK, we need that long-term certainty in order to allow businesses to invest in setting up that supply chain and the accompanying skills. We also need to work with the public to educate everybody on the benefits of supporting that transition, what it will mean to what the impacts will be in terms of disruption, and we've got to try and minimize those, but at least make sure that people have a realistic view of what that will mean going forward. So there's a need for some engagement. How do you finance it? So if we're asking people to invest in heat pumps, for example, which will be more, or on the face of it could be more expensive for a householder compared to a boiler conversion, say, if we're going to do that, is there a mechanism where we can have the benefit that accrues from that in terms of energy saving going forward? Can that be retained by an investor who maybe provides some kind of bond to allow
like the electricity company,
to invest?
You'd have a cheaper bill, that sort of thing.
Yeah, it could be. So I mean, there are savings to be had, but if you're asking, but it will take, the payback period will be over a long time, and if you are thinking you might move house, how do you recover that value? And it may be that a third party provides the finance and gets the benefit in order to allow that transition. So those kind of things need thinking about to put them in place. But it's those kind of mechanisms that we need, but on a very much longer time frame than some of the grant schemes have been available in the past would be sort of my view.
Just one sort of final point is that electricity consumptions, could double, potentially even triple or quadruple, depending on your scenario and whether you electrify simply, all of heating, all of transport, sort of thing. Can we simply do it? Because I mean, you were saying 20% electricity out of current energy, and while that's been a great success story in decarbonising it as much as we've done so far, that has taken probably since 10, 15 years. Have we simply got the time to transmission, distribution networks and so on? Can we do it fast enough if we're potentially going at that rate of electrification and decarbonising it?
It's a good question, and it undoubtedly is a challenge. So I think if you look at the target for generating 40 or having 40 gigawatts of offshore wind capacity by 2030, that's a challenge. It can be done, but only if everything is in place to support it. So that there will be. We aren't the only country in the world that is trying to go on this transition, trying to increase the offshore wind capacity. So there will be supply chain pressures and constraints to support that. A lot of that, the capacity that's being developed here, is going to be offshore. So how do we bring that the power into the network here? Create some challenges. So there's work that needs to be done on reinforcing the onshore network to allow for that. I mean, National Grid has plans in place to do that development, but it's a challenging program. And some of the challenges are around how quickly you can get sort of planning consent to do that and make sure that it's done in an acceptable from an environmental point of view way as well. So the speed with which we get through some of those processes will be a challenge. And minimizing the impact on local communities, etc., will be an important part of that. So all things that can be done if the will is there. I think certainty quickly is probably one of the key things. If we have a plan that's credible to deliver what we need to by 2030, and let's just worry about the next decade for now. If we have that in place, we'll get the investment, etc. But we need that plan to be pretty sure to complete the
cynical view here on the will. You were saying someone's written really staffing and action timescales. This is a can which will be politically kicked down the road equals ignored. Then a panic stroke crisis is can't deliver. That's more a statement than a question, but taking a slight.
We certainly need a plan quickly. I think most people would agree with that.
Can I jump in on? Sorry, Tim.
Yeah, no. Do so.
Yes, I agree with everything Di said, and I think there's also another interesting point around the limited space in the UK offshore. I think at the moment there's been great development in the offshore and the net zero technologies, but I think there's also a coordination piece as well. For example, CO2 storage development where it is offshore and offshore wind development sometimes overlapping where the best sites may be. So I think there is a sort of a coordination piece in the net zero, making sure that the interconnectors, the offshore wind sort of facilities, the CO2 storage facilities, potential hydrogen storage in the future as well, is developed in a way which doesn't impede one technology over another, and make sure there's actually a sort of a pathway strategy to developing these assets in the offshore space. I think also if you consider the decommissioning of oil and gas assets, which can provide potential opportunities for some areas as well. So the Crown Estate's just launched a co-location forum with the offshore wind industry, the oil and gas industry, and CCS groups in there, and I think these kind of groups are really important to establish early, so we can try to understand how we're going to enable these huge sort of changes to our electricity and energy system, particularly in the offshore space, which it may get quite crowded quite quickly.
I think that's a really good point that Chris has made. You know, the North Sea is a huge asset for us from an energy point of view, but something that we need to manage well. For people that aren't familiar, the government has a project called the Offshore Transmission Network Review ongoing at the moment, and the aim of that is to look at how sort of an offshore transmission network can be coordinated to make it more efficient, to make it more resilient, but also to sort of minimise the environmental impact of collecting all of the power from offshore generation. They're running a webinar next week. So if people are interested in learning about what's going on there, and it's tackling a lot of the issues that Chris just raised, and I think it's on the 22nd of July. If you look for the OTNR website, you can register for that if people are interested.
That's great. There's a final question actually. What role do you see for ocean current turbines? Any views on that? No.
Maybe one for me. I mean, the sort of tidal flow and wave generation is a bit. The technology is further back in terms of its development. I mean, there are some sort of larger scale installations have recently been installed. The next round of CFD auctions, the structure of the way that the auctions are done will make it more feasible for marine technologies to compete in that. And get some commercial contracts, and I think that's what that sector needs. Is it needs to get for it to be feasible to set up some commercial operations to start bringing down the cost of technologies. I think we've seen how quickly wind and solar production costs have dropped. And that the marine energy sector is still at the sort of start of that curve and needs to move up it quickly in order to compete. So I mean, my view would be that it does have a role to play in the future, but which technologies can get down that curve, the cost curve, quickly, is something that is still to be proven. But at least they'll get the chance to do that now, hopefully.
It says wind has generated less than 2 gigawatts per day for the past 5 days, normally 10 gigawatts plus. How is this going to be dealt with? I assume that means how's it going to be dealt with, especially when that multiplies in the future, that sort of differential.
I mean, the sort of capacity factor for wind is part of all of the models that people run for the scenarios. So it will be intermittent. The sort of theoretical capacity will be higher than the actual capacity, and that's why the future energy system needs to be a mix of lots of things. So we need a lot of generation, but we also need backup, whether that's hydrogen, whether that's battery storage, whether that's interconnection to other countries' supply, whether that's the existing nuclear or sort of future nuclear program. We need a mix of everything, because we are going to have days or even extended periods when the wind won't be generating anywhere near peak capacity.
Great. No, that's
I'm nodding along with that one. I agree, and obviously for us, this gas CCS has a key role, and bioenergy CCS as well, providing some of that sort of fixed and reliable generation capacity for particularly in the winter period when demand for energy is going to go up quite significantly with electrification of heating as well.
yes. We're drawing almost to a close now. I think there's no more questions. So, unless there's any specific points either of you'd like to make, I think we've covered the idea and the broad themes that we're moving towards. And thank you very much for actually taking part in today, both Diane and Chris. And don't forget, we have more keynote sessions later today, or not later today, sorry, tomorrow, covering the decarbonising industry and commerce and no regret first solutions, and also the decarbonisation of transport. And during Net Zero Week, which actually officially kicks off Saturday, and Saturday to Friday next week, we've got over 35 free to attend live events, all exclusively curated for Net Zero Week and to help you on your net zero journey. Lastly, a big thank you to all partners and sponsors. There's over 50 collaborators who have made the week, National Awareness Week, possible, in particular Northern Gas and Power, our principal sponsor, and Hitachi ABB Grids, our co-sponsor. And thank you, as I say, thanks so much for Chris and Diane. Thank you, audience, for listening and for all your many questions. Thank you.
Thanks for having us.
Cheers.
Thank you for having us, and thanks for the good questions.
Yeah, no, thank you. Thank you. Goodbye.